Well, hi, good morning. Thanks so much for joining me in my shop here. Just before we get going on a little more work on this meter, doing the alignment, I guess calibration is the right term for it. I just wanted to show you what's happening with the weather here. Okay, so you're looking at a weather map here. I live right where the finger is on the hand there. You can see this line of snow just about to hit. Behind it is some freezing rain, and behind that is a lot more rain going all the way down here. I'll play the animation here. So it's very close to my house now. This is going to dump 20 centimeters of snow onto my house today, and pretty much all this area here. Maybe some freezing rain, but it may just stay snow up where I am. And then all this moisture. So this is typical of a storm. Two kinds of storms we get here. One is the moisture comes up from the Gulf and flows up, well, just like you see it, exactly like you see it, and produces rain or snow in the winter up here. And the other one is storms that come across from over here on the west coast, and they just work their way across. Depends upon where the jet stream is. Just how these storms develop. But there's going to be a whopper, and you can take a look outside. So just other than that person walking by, there's nothing happening out here yet. You can see it's a little bit windy. Some of the weeds are blowing a little bit. I'm very, very sheltered in this location from the wind. So there's my driveway, which I cleared out yesterday to get it all ready. And on my lawn right now is about 1.5 feet of snow. I think I said 3 feet a video ago. I was a little excited. Maybe 1.5 feet out here. And that's going to go up by another 1.5 feet, something like that. We will see, because the snow starts in just a few minutes. Okay, let's go and look at a voltmeter. Okay, so the objective of today is really kind of twofold. Just fix my microphone gain there. It's really twofold. One is to finish the alignment on the, maybe 3 or 4-fold in fact. Finish the calibration of this unit. Then I want to revert back to this one at some point, which wouldn't zero properly, and with a little bit of prompting, maybe the 12AU7 tube in here is worn out, and if I test it or put a new one in, I'll get this guy working properly. It won't zero on AC, and as I remember, right? And we'll see if this one calibrates. This one was reading quite wildly before I corrected the main problem, which was the high voltage supply, capacitor and rectifier. The main problem in this thing is this selenium rectifier with a huge voltage drop across it. Therefore, it's developing a fair bit of power or wattage being developed in here. This guy was killing everything. Not surprising. So the other thing I've done here, let's see, last night is in order to ready this meter for full work, I've added, let's see, okay. So I have the proper probe with the switchable 1 million ohm resistor in the end of it, and I just established this grounding clip lead out of the connector. That's all was missing before. Okay, so that meter is ready to go, and of course this probe can be used in the other almost identical meter over here. I haven't yet built another probe. I'll do that. Just got a little late last night. Likewise on this one, because it came with these little terminals here, these little ones that are looking for some unusual size of I don't have the right size for those, so I replaced them last night with standard sized banana plug type guys here. So that's what I was doing last night, rather than sitting around in front of the TV. The other thing I did last night, I did a lot of stuff last night. Let's see, I moved this voltmeter. This is the voltmeter that reflects the voltage on the end of the power cord. You see the power cord can extend much further out onto my bench today than it could before, partially because of relocating this. And I've also gone ahead and included an inline fuse in the power line coming to this outlet, which is what I plug all the workpieces in. So in here right now is a 3 amp glass type fuse sitting in there. So prior to putting a fuse in here, there's a chance that it could develop a short circuit, not with the dim lights switched in. Without the dim lights switched in, maybe I could walk out of my shop, the piece of equipment I'm working on, maybe a tool falls into it, who knows what might happen. A really heavy short circuit develops. It may not be enough to open the breaker in my house. It'll certainly be enough to pop this fuse now. So that particular scenario I don't believe can happen in here. Or it's much less, I think the proper way to say it is it's far less likely to happen, because goodness knows everything under the sun happens in this shop. Okay, though I also was muttering in the last couple of videos about having a voltmeter, to like an older style voltmeter, to compare with these VTVMs on some of the measurements here and there, and I forgot I have this. This is a very much like a to me like late 40s, you know, it could be early 40s meter. I checked this guy out, he works pretty good. This would be the technician's meter for doing this kind of work. If he didn't have one of these, he'd be lucky to have one of these. This guy doesn't have the impedance on it, but I do remember doing some tests on it and measuring it and finding out that it's not so bad, but it's not so good. So I can use this as a comparator meter, for instance measuring the AC voltages between cases. Those voltages don't have much charge available behind them, so as soon as you try to read them, you can draw the charge away, or if you touch them with your hands, you can dissipate the charge through your body and not even know it. No need to talk about all that stuff though, Jim. And this was another not quite finished project here, making another pointer up with the resistor in it. I'll have to do that maybe tonight, maybe later today, because I'm going to be snowed in. So in thinking about this a little more too, how surprised I am that all three of these meters that I have, they all look so different. Really, this one, and this one appear to be identical meters electronically. They appear to be the same thing. They're laid out the same, everything's the same. And they were both kits. So there could be some relationship between the two kit companies, Heathkit and this was Allied Radio. Maybe there was a relationship there. And so far I'm leaving in this really high voltage capacitor that's in there, 1600 volt capacitor. I've done that on all three of them. That capacitor is not part of the electronics per se, but if it's bad, it would affect, I think it's AC readings. The other thing I learned about this meter, and like all three of these meters now, which I find kind of a little bit surprising, is when you switch it to AC, what the meter does is it sends the AC signal you're testing through a full wave rectifier based on a 6AL5 tube, and then takes the rectified output and basically presents it to the DC voltmeter at that point. I mean, all these meters are DC voltmeters. It's DC that drives the pointer. They're all ultimately DC, no matter what you start with. What are your options? AC and DC. Not too many options. So I just was interesting. It's just interesting to me that that's simply what they do. And of course, it's all done in a calibrated manner, so you can get calibrated readings on the face of it. Pretty simple stuff. Let's calibrate this guy here. Now everything I'm sort of using stuff for the first time here since I fiddled with it. Let's put that there. Now I'm going to want to be reading some voltages here. Good. Get a lead for here. hook it up to this voltage supply here. Put DC 20 volts on it. This guy's on already. No. There we go. Everything looks proper. We're switched to DC plus volts on the 50 volt scale. It should be reading already. I have the leads hooked up properly. Okay, let's disconnect here. The 0 is way under. Oh man. It won't come close to 0. Switch scales, it's jumping around it, but it's pinned backwards. Okay, let me cut the power here for a sec. Let's see if the meter drifts up. Now I got two interesting comments about checking the meter movement. What do you say we check the meter movements on 50 meters quickly? A small aside, this is my box of meters. How I've acquired this over the years, I don't know. Let's start with this one. So, you know, I say, is that a good meter? So you just rock it a bit. When you see the pointer fly around, well, you know the pointer's loose. And if you just hold it still, it comes pretty close to 0. That's not bad. This is a kind of a cheapo old meter. It says DC volts on it. Check this one out. This is a beauty. Again, is it good? See the pointer move? I mean, it doesn't tell you it's calibrating right or anything. I like it though. So, but let's check this one. Pointer not moving, and you can see there's something funny about the pointer in here. It's been forward or something. Maybe it's stuck on the glass here. I don't know. Something wrong with it. Anyway, that's just a simple thing you can do. These meters, cool, eh? I've just got an endless supply. There's a center one. Kinds of them in here. That's the same as that one. That's another one of those. Bags. Meters. I think this one is a push to check meter. Push it. Is that a switch? Kind of sounds like it. These are probably all specific to certain radios, of course. I got 4 of these. 1, 2, 3, 4, 5 meters. Anyway, I won't go through the rest of them. The point I've already made is if you want a quick check on a meter movement, you just rotate it a bit. That's kind of common sense. I'm probably not telling you anything that's blatantly obvious, but give me a chance to show off all my little meters there. Goodness knows what I'll ever do with them. So an issue with these meters would be how strong is the spring that's in them. Has a spring lost its springiness? And some of these may have a counterbalance weight in them. Excuse me. So let's see. So I got to stand this up properly now to do what I'm going to do next. Can't be fooling around with these now. Didn't I adjust the 0 on this already? So the meter's switched off. There's no power in it at all. Oh, it just popped up. Uh-oh. Oh. Well, that's better now. I wonder if it was stuck on something there. Yeah, lots of problems. These meter movements, of course, are extremely delicate, so all kinds of things can happen. Now, I zeroed it, and then I tipped it on its side, and I don't know if you can see it, but it's actually under 0 now. Let's go back up vertically. It's kind of counterintuitive. It's under again. Something going on with this meter. Okay, so do what you said, John. So it's wiggling free there. Put it on its side. It tips back. Almost suggests there's a counterweight pulling it under. And then I straighten it back up. There's nothing I'm going to be able to do about this. I'm just curious, as usual. It's a little under, and then it pops up. Let's take a close look right in there. Let's go right in there. Okay, I'll focus this in a second. As soon as I just get my camera steadied up here. Let's see if we can see in there. It's a curious what that is on here. What's this? Oh. So this is a piece of metal. This is a piece of wire, and it's stuck on the front of the plastic. It must be held on by a static charge. Now, I got another comment about static charges here on these meters, which I will fool with in a moment, but it probably can't appreciate it. That's just hanging there. Let me get the big camera on it again. So I didn't think this was even possible. There it is. Can you see it? On that? You can kind of see it. I didn't think it was really possible for this to happen. So there's assumably there's a static charge on that wire, even though I've touched it with this, and it's attracted to the plastic here. Really? Never mind electronics. Let's check this out. This is something weird here. You can see it there, right there. Can't you bleed away the charge and it would just drop? What is holding that on there? Is there a magnet holding it on there? It's really held on. It's got to be a magnet. It's got to be the magnet down here, and this must be a steel. This would be a lead from a component. It's a plated steel. The magnet is that strong? Yikes. It's still hard to believe. Oh my gosh. Oh, look at that. It's standing on it. Yeah, that thunder you hear is cats running around upstairs. That's the sound of 12 feet pounding away. Isn't that bizarre? Oh, you can't quite see what I'm up to here. Or can you? Oh. So is this thing now tipped on the angle of the magnetic field? It's on a funny angle. It's a little hard to appreciate in the camera. Is that what that's showing? the shape of the magnetic field, and I can distort it here. And a piece of steel. I need a nice piece of I don't know. This has got to be steel. Big hunking piece of steel. Oh yeah. So I should be able to convey the magnetic field. The magnet will be down in here somewhere. Actually, you can probably see the poles right at the top there. So if I can get in there, I'll magnetize my powerful, yeah. No magnetism really in the screwdriver, oddly enough. Well, the only importance of this, I guess, would be watch out. Bits and pieces can fly up and get stuck on your meter. Magnetic pieces. Unbelievable. Now, what's this telling me about everything? Well, it's not telling me anything about anything. Just having fun. But tells me the hey, what about the other meters? Are they as strong? Son of a gun. Exactly the same. Uh-oh. Where'd it go? There it is. Huh. Yeah, same thing here. I had no idea they were that strong. Okay, another lesson learned. So, let's keep the lesson going. Sure. Yep, rolled up here. Doesn't take much to fascinate me, you know. That's the deal here. I'm not very demanding when it comes to that. Be entertained with very little. Good. So we'll fire this guy back up, and we'll do the alignment thing, and we'll see if it corrects any of the stuff. So I'll hook back up to the 20 volts here. Yikes. Yikes. Okay. So I can see already that's not coming out right. I think I may have clipped onto the wrong wrong meter, positive, earlier. So what do we got happening here? We got 20 volts for sure on the end of these wires here, and we got the meter telling us it's 150 volts. 20 volts is showing up as 150 volts. The meter reads the difference between the cathode potentials or something in the cathode circuits of the two sections of the 12AU7 tube. So if the two cathode voltages, or the points where this movement is connected, the exact points in the circuit, if they exhibit a common, let's call it a common mode voltage, then the meter sees nothing, and it will just sit on 0. And so the idea is the incoming signal is conditioned and used in such a way as to raise, I'm not sure if it's one or both of the voltages here. If it raises one, there's a difference voltage that the meter will see. But it could even raise 2 in a proportional manner. You could be doing this kind of thing, I'm not sure. But all of it is sort of held arithmetically to being proportional. So the difference in the voltage still proportionally reflects the voltage coming in or being tested. So how do you get 150 on here? Well, that means that these two cathodes got to be like this. And the first hint that comes to my mind is the 12AU7 is shot. Sounds like a tube test right off the bat. I was thinking about doing this on the other two 12AU7s too, but for sure, let's do it on this one. Control the power here. And I gotta clean I gotta straighten things up a little bit to do the tube test. We'll do it. Okay, so I've got the 12AU7 tube here. I've got the tester set, but let's double check. Always double check. 6.3 because it's using the center tap and the filament and a 12-volt tube. Signal set to 2. Bias is 18H. Button switches are PGK77. PGK77. 3516. 3516. 29 F, very important. 710 is the rejection point, so the tube only has to get above where my finger is now, just above, kind of above the 50 there. You can read it. Well, you can't really read it on the camera, but you'll be able to see it. I think we're all set. Switch on. Now, when I put the tube into the socket here, wow, the socket just feels as loose as can be. You know, most of my tube testing is done over here with a 7-pin socket. It's got more pins, but so I thought, wow, this isn't even going to make contact. But I see the heaters are hot. Heaters are hot. Okay, shorts. None appearing. So let's see, 710 PGK1. K1, P1, G1. These buttons are set to number one position. Twin triode X2 means the actual mutual conductance is double what it shows on the meter. But that's okay. 710 is the number. GM test. This is testing both halves at once, unfortunately. Oh, it's super good. So this tester is testing both halves of this tube at the same time. So if there's a difference between the two halves, we can't see it with this tester. That's unfortunate. Let's see. I'll have to try another tube tester and see if we can test one half and then the other half of the 12AU7. Otherwise, oh, what am I talking about? Okay, ignore everything I just said because somehow I had a brain infarction. Put these here. Now we're going to test the other half. Okay, so the reading here, because we need similar readings here. So the reading here is 1,000, 1,500, 11 is 1,200, almost exactly. See what happened there? Well, that's probably the loose socket. No? What happened? Just find out there's something wrong with that. Hey! Is it the tube or is it the tester? Same reading there. Now it's working. Let's just hang on a bit. Hey. Yeah, it's got to be the, well, I don't know, socket. Tube. Okay, now we're going to do the real tube testing. I'm going to get another 12AU7, stick it in the meter, see if the meter works better. And I also have another, I'll look at my other tube tester and see if I can test the two halves of a 12AU7 separately. What am I talking about again? What is with me? Funny, you know, you get ideas stuck in your head, you just can't get them out. I can't get it out. Okay, let's take a look at the radar. It's about 9:30 here now. So the radar, I'm under snow here according to the radar. Quite a bit actually, because I'm located right down in here. Let's play this animation. That's what it shows. So I have another weather radar here. It's not quite as good. Let's just update it. There we are. So I'm right here. Boom, snow, heavy snow, supposedly, but this is what it looks like outside. Looks like that. There's some wind blowing a little bit of snow across my driveway, but no snow falling. Great. Okay, well I did manage to find a few more 12 AU7s here to pick from. These are all 12 AU7s. Probably got more if I spent more time looking. I'd probably find more. There you can see the box of tube collection down here. I think I've showed this once before. I bought these at a yard sale for not much money. Just like that. Store your tubes carefully. See, that one's all white and it's shot. Looks like a, oh, you can see the cracks in the glass. It's smashed. Wow, what have I been doing with these? That's a test. It looks like a 6AL5. The other tube that's in the meter. I'm going to test that. That's a piece of junk, unfortunately. So I'm going to test a bunch of these. Maybe I'm going to test all of them and weed out the bad ones. I might as well do that. And we'll see what kind of difference I get out of this. Yeah, let's just go at it here. Okay, shorts. Nope. Ones. Good. They're on the same reading of 12. Only needs to get up to about here, 7. Low on this side. So now there's a tube with a difference. One side like that, 1/2. 1/2 like, oh, what was that? What is going on with my tube tester there? So I would say, you know, this guy might work in some applications, depends upon what you're putting them in, but in a tube, you need the both sides of this, in a tube. In a voltmeter of the sort I've got, both sides of these have to be working the same. I'm pretty sure that's going to be a factor. Now I'm going to end up having to sort these tubes out. So that's good, sort of. This guy. Doesn't look too good there. So you got one side showing about 1,000, which would be good. The other side showing dead. Now, is it my tube tester? So I'm gonna, yeah, it's my tube tester. It's the socket. It's gonna make this whole thing quite tricky and unreliable. So we got about 1,000 there, and about the same here. So this is a tube with some wear on it, but it's balanced. Regency, manufactured by Regency. Oh. Still warming up. So that's a little under 1,000. Over 1,000. A little under 1,000. So again, the tube is probably good in many applications. Maybe not what I'm looking for. I'm looking for a strong and balanced tube. Why not? also about 1,000. A little higher on the other half. Take that balanced one and set it as, even though it seemed a little weak, since it seems like finding these things balanced is not as easy as I might have thought. Probably in a lot of applications, these tubes sit in devices that use each half differently, and run each half differently, and therefore each half has a different history, different stages of wearing out. It's a little stronger, a little over 1,000, way over 1,000. I'm theorizing that these tubes have to match the two sections, but there is a balancing adjustment to compensate for differences in the two tubes, as long as the differences aren't too extraordinary. So I don't need one that's perfectly well balanced. I just need one that isn't really terrible, I would think. Feels as loose as can be. Still warming up. I know some tubes, when you put them in, they're glowing really brightly, and others are not. The same tube designation. So that's just a little over the 750. It was 750, wasn't it? 710. Okay. Oh, there's a dud. Is it? No, it's the tester. Can't trust this at all. Doesn't seem like anything I can do can really get this to stay up there. What's up? There it is. Socket is shot. Could be that this tester took a real beating in the 12-volt socket in the previous owner. So that's around 1,000. We're all testing very similar, right? Okay. Well, I don't know if this. We can still find a completely dead tube. I have one. Not that I want to find a dead tube. Here's a good one. It's coming right up. 1250. Yeah, there we are. This will be the tube. I don't think they're going to get any closer than that. Strong and balanced. Let's keep going. I got 6 more or so to do. I can eliminate a really bad one out of my collection here. I'm impressed. These are all pretty good, actually. They're not terrible. It's going to be similar to the last one. Very similar. Very close. Balance. Pulling this one out too, because I have a feeling I'm going to be changing another one of these 1287s in the other meter. Pins are bent on this one. I don't have a pins. Yeah, this has been like whacked over inside something. no shorts. Well, dead, I think is the name of the game there. And it's heating up. Yep, heaters are on. Heaters are on, nobody's home. I think that's a dead. The dead to this one. There we go. It makes the pilot light dip when they first plug these in. Shorts. Hey, 2 in a row like this? What's happening? I don't believe it. Okay, back with a good one. This is one I tested previously at red upscale. Something funny going on here. Don't throw your tubes around, Jim. Well, okay, 2 dead ones in a row. That's just a little, after all those good ones, seems a little odd. Okay, gonna test a good one now. Feel better again? 'Cause now I'm wondering about the tube tester. Oh, come on. Come on. Something's going on here. I'm going to have to take my... this is going to become an issue here. Look at that. It's a pretty good balanced one too. Bring back. Bring back this one. So this one tested dead previously. Hey. This one up. Look at it. Look at that. Can you see that? Oh, barely. What's happened to the camera? You did see it though. So this one up. And back down. Maybe that might indicate the heater disconnected in here. Yeah, I think that's all that was. Heaters are flaring up now nicely. Here it goes. A lot of trouble with the socket here. That's really what's happening. Okay, so it goes way up there and then it came back down on its own. Wow, that's the highest one yet. There it goes. Oh, look. Now, it's moving a little bit. You probably can't see it. But I have the feeling it's probably heater disengaging. Now, let's just try the other side here. Okay, so the other side's alive too, and wow, very strong. Yeah, I'm willing to bet it's nothing more than this socket. I mean, who would be surprised if tube socket wears out on a tube tester. Surely that's not a surprising deal. Now, this is also one I tested bad. Okay, both heaters are on. And this is a real McCoy bad one. Oh man. Okay, I think this is a real McCoy bad one. The next one after it was a fake. Oh my gosh. I'm telling you, this is why when I have medical tests done, which is very, very seldom if I ever have medical tests done. If I were to have a medical test done and the doctor were to present it to me and say, this test requires us to take this following action, I would start asking a lot of questions about the test. And if the action was serious, like, you'll have to do this for the rest of your life, or never again will you be able to do that, if it's some kind of really serious thing, I'd have the test done again. I certainly would. Especially if I'm the one doing the test. Okay. Or if I find out they're taking my blood sample and sticking it into an old tube tester, that would be... Oh, weak one. Very weak. That's actually below the minimum. This is weak. This is a weak one. So this guy's good, but he's worn out. Actually worn out. So what this tube tester tells you, the number it gives you down here is called the reject point. They don't give you a number and say it's good. They give you a number and say if it's anything less than this, it's bad. Which I guess makes a lot of sense. .12AU7 is very popular tubes in television sets, old television sets, I'm pretty sure. Ain't no shorts. Another weak one. Come on, tube tester. Are you kidding me? You just kind of jerking me around here? Weak on both sides. Really? Okay, I'm going to stick back in the known good one. After testing two tubes identically there, I get a little one. Two tubes poorly identically. Get a little nerve-wracked. So this guy shot the pointer almost up to 2,000. He's going to get there again. There we go. Yeah, you know what? I'm not sure. I'm sure this thing went up to 2,000. Going on here. Well, I'm not sure these tube tests are valid now. I think maybe what's happening is even as I test these tubes, because I seldom use the 12-volt socket, I am wearing out what little life is left in it right here, and killing it right in front of us here. Squeezing out the last bit of life. So I don't think I've ever had this apart. Could be wrong about that. It might be interesting to look underneath, see what's under there. That's a beauty. Stable. What goes on with these tubes? Put one tube in and wiggle it and it looks like the contacts are shot. Put this tube in, looks fine till I do this. Oh. That's under 1,000 there. Over 1,000 there, so it's out of balance. A tube that's out of balance, or my tube tester is just jerking me around something terrible. Don't think so in this case. I think it's out of balance. That's the end of it, thank God, on that. what did we end up with? So we ended up with 3 alternate tubes that are strong and balanced. These 3 here, and 2 more not so strong but balanced tubes here. So I got lots to choose from. And what about the original one? Let's just go ahead. Just put in the original one. Oh my god. Is this the original one? What have I done with the original? Goodness only knows. Well, on the basis that this might be the original one left here. Oh, terrible, terrible job. It's okay. Ultimately, I'll have a working voltmeter. It doesn't matter. None of this really matters. Nothing really matters. Isn't there a song that says that? This is the tube I just finished testing. So I don't know what happened to the original. I think it's on the bench. I don't know. It's mixed up. I think it's one of these two. Not those. Not those. Those are definitely the good guys. Okay, so we'll pop one of these in. We'll put the good guys here. We'll put the sort of good guys over here for some reason. And we'll put these out of balance but still working ones back in the can here. Okay, good. Pop this one in. So what we saw before was enormously high readings. So we still have 20 volts right here. We're all set to go here. I'll let her rip. We're on the 150 volt scale, so I mean this should just come up here. Oh yeah. That just might be a warm-up thing. Or yeah. I think we're going to be looking for a bad resistor somewhere in this set here. Let's take this one off. Well, it's way out of balance too. So let's fill around with. Let's do a quick hack job on the adjustments back here. Did they not? Yeah, DC calibrate, AC balance. AC balance. Is that the one to start fiddling with? I don't think so. That one we're in the DC calibrate, DC balance must be down here. Got it. Oh, hard to get the screwdriver in there. I don't like using 2 hands. Oh. Well, I can't tell what's happening here. Am I in? Yeah, I think there's a component problem because this adjustment's doing next to nothing. Oh, maybe I just didn't have it zeroed. Duh. Yeah, put a new tube in. Yeah. You gotta zero it. So, where'd it go? Okay. Grab the right control. Calm yourself. Oh, do you see it jump there? So, something going on. This pointer sticks. The meter sticks down here. And you have to get enough power to overcome it. There. Now there's a stick point right around the 0. Right there. Ooh, that's not so good either. What can you do about that? Or in a pile of WD-40. Okay, so that's roughly the 0. And now let's see what we get. What do we get? Oh, that's a lot better, isn't it? So we're definitely putting in 20 volts. We're switched on to the 150 volt scale, and that's reading roughly double, almost 40. So if we go to the 50 volt scale, 20 should be down here. It's reading way up here. Still reading too high. Maybe it's just DC calibration at this point. So we'll try that. I mean, maybe the tube was going bad over a period of time, and somebody kept recalibrating the unit. Okay, this calibration control is right at its limit. So let's take off the so 20. So this is 20. So I set that right on 20. Maybe that's all it takes. 20. We'll check the 0. 0 looks good. 20 volts. What am I complaining about? It's reading fine. 20 volts. Let's give it so 20 volts. So if I crank this back to 10, or let's say around 15. So this is around 15 on a little inaccurate meter. I'll flip this to the 15 volt scale. Ah, right over nicely. Okay, and the AC balance. I need to flip that onto AC volts, and then you just make the meter come to 0, I believe. Let's see. Come to 0. Maybe not. Better read up on how to do the AC volt. Maybe we're shoving 10 volts DC into it. No, we're not, because the AC is here. So if we wanted to read AC, I haven't really built myself a prod for this yet. What do we got? Oh, this is kind of a clunky deal to sort. Here we are. Try to read an AC voltage with this. A nice handy AC voltage. Something a little safer than what I was doing last time. What would that be? That would be, oh boy, I don't know if I can find it. That would be a, no, I'm not going to find it. That would be a transformer I have that develops the right voltage to run jukebox remote controls, but don't know where that is. We'll do the 120 volt thing again. I don't like doing that. Let's do it though. We're going to do it. Okay, 120 volts, and we're going to be reading, this will be powered from, still powered from the isolation transformer, but the voltage on this wire will be regular house voltage. Does that mean there's a risk of doing this backwards and getting a big boom? That's scary stuff. I don't think there is, but it's scary. I still find it scary. Okay, let's not be too scared. Let's be bold. Be bold about it. Jim. So we'll now hook up one of these two. Let's assume I was really smart and made the green one with the ground. Rather than do this with my hands, bridging things. Pull it out. Put this here. Again, if I expected something bad to happen, I certainly wouldn't do this. Boom! I shouldn't do that. Shouldn't do that either. Now we want to read the voltage on here. It should be 0, 0. Jim, do it right. Do it right. Take that off. Well, that's okay. We can leave that there. We can leave that there. This has to go. This is the ground. Okay, this is the one that's a little bit scary. But it isn't really. It is, but it isn't really. Yes, it is scary. What a chicken I am, man. All I'm essentially doing is hooking this to ground. I mean, come on, this can't be scary at all. I just got myself so spooked out here by the stuff I've been doing. Okay, now one of these is going to be alive at 120 volts. Let's find out which one. Let's find out which one once and for all. And we'll do that with this other meter. We're going to assume the red one. Yeah, what am I? Yeah, just had to stop and think hard for a minute what I'm doing. Too many leads on the bench. So this we want to touch to a ground and see if we can see voltage on this test lead. Oh, ever awkward. Okay, watching the meter. Nothing. Okay, so probably the meter was connected to the grounded terminal. So I'll take it off. We'll put this on the green. This is now probably the live terminal. Ready here, ready there, ready everywhere. On the ground. There we are, live terminal. Okay, so now we know the green one is the live one. Red one is the ground. So we'll go red one onto the black one. See, it's just terrible, isn't it? How I covered it. Shame on me. Should have checked that out. And now on the AC connection, can I just go like this? There we are. Meter set to AC, scale is set to 150, and voltage applied. Okay, voltage taken away. The meter's not zeroing. Is that not the AC balance control here that does that? Moves it ever so slightly. Just the tiniest little bit. That doesn't seem right. Okay, power. Oh, well, it might be reading because there's a junk signal coming into it. Doesn't seem to be the case. Just one hand, Joe. Phew. How do accidents happen? So I clipped this clip on here. It didn't hold. It popped off and fired backwards back into my hand, where I grabbed it, luckily, by the insulation. But I could have easily fired it back into my hand far enough for me to touch the contact. No problem. Power's off. But that's how accidents happen. Unexpected little things like that. Who would think? That clip lead's going to fire into my hand. Who would think that? Famous last thoughts. Okay, we're ready now. We're going to put the power on there and read the voltage. Meter's on its side, so how accurate can this be? So we would read this on the 150 volt scale, DC or RMS. So that's reading 94 volts or something like that. It can't be correct. So we certainly got problems with this meter. I can't seem to derive any accuracy out of it. Have I done anything wrong here? I don't think so. I think this is all hooked up appropriately. Let's fool around with a zero adjust. What's that do? Well, that moves the meter a long ways. You know, it wasn't zeroing on AC. So let's force the zero on AC. Signal's gone. And this will just make it read even lower. There's the correct zero using this. I mean, there's a reason why they have these controls up front on this meter. They expected to use a lot. So now it's around 80, 83 or something instead of the 115 it should be. Let's see how the snow is going. Well, as you can see, my driveway has gone from black to white. The snow is falling. The storm has started. My neighbors, all three of his vehicles are out and gone. So the expectation is this is going to be 1.5 feet of snow by tonight. So my wife and I have prepared for this. We're ready to hole up in our house for a couple of days straight. And okay, spring seems to be disappearing here. Well, after all this, I think the conclusion I should really reach is that there is a component problem inside, component level problem inside here that has to be tracked down and rooted out. So that's what we're going to do from here. I'm pretty sure the 12EU7 that's in there now is definitely a fine tube and should not present a problem. So that's what we'll do. We'll go through, check voltages and things like that. See if something's out of sorts. That'll be on the next video. So thanks a lot for watching, and in the meantime, the blizzard has started out there. You know, this camera doesn't really do it justice, of course, but the snow is really coming down, and if it snows like this, as they are predicting at this kind of rate, then yeah, I will get a couple feet of snow here today. So see that? We'll see what's left of that tomorrow. And let's just watch this woman pushing her baby buggy and her dog. Now you say, what is she doing out there? She knows that this is her last chance to get out for a walk. So she's going now. Look at that buggy. Look at the snow tires on that thing. Holy smokes. She's not beating around the bush either, is she? Dog or no dog, she's carrying on. Right now, my cats are no doubt upstairs looking out the window at this. This is what they watch all day long. Poor dog. Get up there, buddy. Okay, and if we stood here long enough, we might even see the mailman come showing up later. But that's it for today. So thanks so much for watching my video, all my videos. And tomorrow we will troubleshoot this thing and try to find out what's gone wrong in it. So, see ya.